Hi there, welcome back to iHireRobots. My name is Stephen McKinney.
And I'm Eric Stentrup, and I almost forgot last week, and Stephen saved my butt on that one. All 6 of these episodes are sponsored by United States Army, which we appreciate, and a little shout out to them. This week, what are we talking about?
This is the only week we're actually going to talk about something technical. Everything else is kind of team related, but this is the only week we're doing a technical one, and it is programming. And we're here with Brandon of our team. Go ahead and introduce yourself, Brandon.
Yeah, I'm Brandon Hjelstrom. I've been on the team for 3 years. I've been programming for quite a while.
And a little background knowledge, your dad's been our mentor for programming since 2006. 2006, yeah.
Yeah.
So it's in the blood. It's in the blood. I don't know. Kevin's here and he wants to do pneumatics. Yeah. All right. Well, go ahead.
Cool. So we had the chance to chat with Code Orange also earlier in the week, and we'll have the interview from them later on in the show. For right now, we're just going to ask Brandon kind of the same kind of questions and just talk about programming. It's hard to get into specifics. As anybody that has coded a robot knows, it's going to be completely different from robot to robot. But what do you think is the easiest programming language to use? And now, I'll preface this by saying there's no right answer to this, because Code Orange claimed, they said that LabView is the easiest for them to use because that's what they knew. They didn't have anybody else that was familiar with Java or C++.
Right, so the common answer for that question is LabView. But in reality, you should choose whatever language your programmer wants to use. Because in the end, he's going to be programming the robot or she. And you don't want to have to spend the build season learning a new language. So definitely go with what your programmer knows. If you're a completely new team, then I'd recommend LabView as well.
Do you kind of think people go towards LabView because it's a drag and drop, similar to if you had maybe started out in FLL?
Right.
It's the next progression, so it's something that you're comfortable in, you know?
Yeah, definitely. If you're coming from FLL, if you're coming from VEX with EZC, then LabView is the way to go.
Back in the day when I used to program RCX bricks, it was basically just a really watered down version of LabView. It literally was made by NI, I believe. So, next question is, what programming language do we use here on 987?
We use C++, and again, that's because I have experience with C++ and other text-based languages. C++, you're able to make some really nasty errors, so that's kind of why I wouldn't recommend it for new teams. But it's great if you want to have full control, maybe more open access to the robot, to the potential features of your robot.
What are the most common languages in the FIRST community?
LabView is the most common language. And then between Java and C++, I'm not sure which one is more commonly used. I'd assume Java.
It's more taught in schools,
right,
for like computer programming.
Well, the new AP test, well, I shouldn't say new, they changed it over like when I was in high school, I think, but the AP Computer Science is a Java course, I believe.
Mm-hmm. Right. So
a lot of schools teach that, and that's why a lot of the teams, I think, use Java.
Mm-hmm. Well, it's applicable to website design and every other application. Also, the dashboard, smart dashboard, using that, writing Java code on that as well. So it kind of overlaps that. What is the process of programming the robot? As far as from once we find out what we're going to be doing, what sensors we're going to put on the robot, what autonomouses we want to run, what do you do at that point?
yeah, so first definitely start with that. When the build season kicks off, you definitely need to keep in mind what sensors you're going to be using, what autonomous modes you're going to start writing. So when your design is getting close to finalized, you can start writing the code that you know is going to be on there. So like the drivetrain code, for example, you can start making drive routines for autonomous, making sure your drive codes are really solid. If you want to start messing around with PID loops or just P loops, that's a good thing to start with. And then make sure you test your code incrementally. So, write the code for your drivetrain, and hopefully you'll be able to test it right when your team's drivetrain is built. So.
Now I know LabView, I'm sure Java, and I'm sure there's a C++ default code out there, correct me if I'm wrong?
Right.
Yeah. Do you use that code, or do you write your own code?
I start with the simple robot template.
Okay.
There are tons of templates to start with, but I just go with simple raw because it's pretty basic. It's easy to get started with. using Screen Steps Live, extremely helpful for new teams especially, because it'll show you new changes to the WPI library, and just things you need to be aware of before you start programming.
Common mistakes that just cause headaches. And you can't throw out, don't forget the 50-foot tether cord when you are at the practice field. You know,
I've forgotten the tether cable thing in every region so far.
So we're buying them a backpack this year. I'm going to put a tether cord or tether cable in my backpack too. But what are the most common mistakes that you see out there that people have?
So first, overcomplication. I see a lot of teams day one that'll message me over CD or ask me through some other method, like how do we get the Connect on our robot? And it's good to be ambitious.
Yeah, the Connect though it's
a challenge.
It is definitely that is.
Code Orange, when I discussed this with them, they trying to remember what they asked. They were like, why did you do the Connect? And I just said I can't really answer for them, but the challenge was certainly part of it. Maybe you can go into further detail on why we used the Connect in 2012.
Yeah, so in 12 we really wanted to be able to shoot from anywhere on the field, and the Connect was capable of giving us really accurate angle readings of the backboard as well as distance to adjust our shooter wheel. So I mean, it was really necessary that year for us.
That's what I said. Is that I mean, it seems like kind of just a flair thing, but no, it's a legitimate. It's probably the best sensor that FIRST was included in the kit of parts ever.
Yeah.
And it was a legitimate thing. We used it for bank angles at the end and everything like that too. The amount of data that you got was crazy from the one sensor. I think there's kind of a misconception maybe that we did it for just just to do it, but no, we legitimately used all the data that we got from the Connect in 2012.
Look, remember all the way back in 2005, Stephen, when they had on top of the center goal for the game.
What, the Vision Tetra? Are you talking
Yeah.
about the Vision Tetra?
And at the championship, I don't remember the team number, and if they're watching, they'll be like, hey, that was us. That almost got it.
It was Wild Stang.
Was it Wild Stang?
Yeah, it was Wild Stang.
Now look back at that.
Yeah, I know, right?
It wouldn't even be,
No, it wouldn't
every
be a
team
big
in the
deal.
nation dang near would be able to do it. It's the same thing with the Connect. Give it a few more years, it'll be a common sensor that'll be on the robot. It's just that you had to have somebody pilot and lead the way. And I think that's where we kind of took the initiative, I think that year, 2012. And but if 254 is watching, what you used the Connect in 2012, it was ingenious. So.
Yeah, that was probably the most
entertaining.
The most entertaining implementation of the Connect.
Yes.
That one.
Yeah, and it'll definitely grow more popular with the new control system, with 2 USB ports and everything.
Do you want to go into a little detail on the new control system? We're going to be demoing it at the San Diego Regional. You can give us a little bit
Vegas.
of an overview.
In Vegas.
Oh, and Vegas as well. So we might could take some footage from the regionals and later on post it onto the iHeart Robots.
We were talking about that in a special episode. Too.
Yeah, absolutely.
Yeah, so we'll go into a lot of detail about that at the regionals. So it should be right next to our pit.
Those of you that are like Stephen and I, we're the back in the day kind of people, have been on robotics for a few years. Just throw it out since we're talking about programming. You're going to like it. It basically is going back to the IFI model of everything integrated as one system.
Similar to the IFI control system, I would say. Just
Yeah.
looking at it now, I can't
Yeah.
speak from a coder standpoint or anything like that. But
Separate power, smaller power distribution board, but then your main board, it's your processor, it is where you plug in your PWMs, everything is all consolidated. The only thing I think is they're probably going to come up with some sort of housing to protect it.
Right, yeah. The alpha boards right now don't have any plastic.
right,
But
a very
it's
naked
just
circuit board looking at
Very exposed, very exposed. What other questions would you throw or any other statements at? I mean, we pretty much hit the main questions. Is there anything that you wouldn't want to throw out there? How do you attract programmers to your team or anything like that? Is there any, because I don't have an answer to that question.
Yeah, it's been kind of lucky that we've just had somebody that
Well, let's throw it out.
wanted to.
So question number 6, we're throwing it out, which I'm sure everybody in the nation would love to know. So Brandon's going to tell us, how do you attract a programmer to your team? Somebody that has those capabilities. They're out in the schools, but how do you search them out and find them and get them on your team?
Well, you need to talk about the programming a lot. A lot of teams, when they're advertising robotics, they get to build a robot. You get to cut parts and things. But you really need to advertise also that you're you're able to code these robots, you're able to learn things that will really benefit you in the future. And then also, one unfortunate thing is that programmers usually don't get the robot till the end of build season. So that's going to discourage 90% of the programmers.
I agree with you wholeheartedly on that one.
Yeah,
So-
and that's something we've changed, I think, as a team
Right.
in the last few years. It's not one of those, all right, now robot's done, now code it.
Yeah.
It's kind of, both kind of work with each other and are synergistic through the build season.
Right, yeah, since 2011, I've noticed we've been really, we have to work as one. From the build season, the programmer needs to have a lot of input in the design, especially regarding sensors, other things like that. But then also make sure you give them the chance to program incrementally. So when you finish a subsystem on the robot, give the programmer a chance to test it out. And if you have an experienced programmer, make sure they're helping them along.
All else fails and you can't attract programmers to your team, what, use Mountain Dew and Red Vines or something, keep a stash of those on hand. So-
exactly.
Yeah.
148 also has some products.
Oh, yes, I forgot. What is it called? It's,
I don't remember.
oh, I'll have to look it up. They have a
It's
fairly
really
humorous
effective.
video, yes, a highly effective product that 148 has on hand for coders.
Oh,
Yeah. So, we talked about going straight for the connect, and it's good to be ambitious, but you need to keep in mind that if your team's goal is to, win the regional or to just perform really well, you need to prioritize pretty effectively. Also with vision processing, a lot of teams say that they want vision processing day one, but they have no plans on how they're going to use it. Even for games that don't require vision processing at all, really. So it's important to make things simple, keep the logic clean. Talking to other people about the logic will help out, especially when you're stuck. So just keeping the code as simple as possible.
I agree, because I know when I'm at competitions too, there's a lot of people that go very complex with their code. And then I think what they do is they know that there's errors, and then they almost, when they get to the competition, they look for those certain teams to see if they can find the errors. But the problem is that those individuals that can find those errors or those mistakes within their code are like your dad. But then your dad, what does he usually do at the Las Vegas
He's
Regional?
a CSA, Control System Advisor.
Yeah, and so those individuals are trying to divvy their time out to 62 teams.
Right.
And it really, really is hard if you have errors that you're looking for help to try and narrow that focus down. Yeah, it's easier, just go simple. Or simple to where somebody else can help you out and add on to it, Encoders. What are some of the specific sensors that you would think are easier to program? Encoders, obviously, you need to know how to do an encoder.
Yeah, encoders are pretty straightforward, but I'd say the best sensors overall are encoders, gyros, and line followers. If there's a line on the field, you should use it, because the line's not going to move ever. It's not dependent on, how rough the carpet is, not dependent on your battery voltage or anything of the sort. So go with line followers, but then encoders and gyros will give you extremely solid drive code.
Yeah, we did the line followers in 11.
In 11.
But then also VEX, if you want to, I want to throw that out to here as well. It's not the same code, it's Robot C or Easy C, but just knowing how these sensors work, they have encoders, they have gyros. But I think for the gyro, do you have to use the Cortex? Or can
for the Cortex.
Yeah, I don't think you can use the PIC system for the gyro. But encoders, line followers.
Yeah, and
They've got all of those sensors for VEX, so it's a nice, comfortable, easy platform to learn on.
Yeah, all of those things are really useful. In 2011, I wrote the autonomous for the robot, and I used the same line following algorithm that I used in my FOL days. So it's okay to keep it simple too. A lot of people don't know this, but we use mostly P loops. A lot of teams use PID loops, and you programmers know what I'm talking about.
It's funny,
Right.
I discussed this with Code Orange too, and I said most of our code is P loops, and they're like, oh yeah, it's the same thing. You use PID just for nomenclature, just so that people know what you're talking about, but in actuality, who really does the integral and the differential? Not that many teams, I'm assuming.
Yeah, there are quite a few that do use them, but you will spend a lot of time tuning those, and sometimes they're just not necessary. If you need a really big arm to be accurate, then yeah, use a PID. But otherwise, P loops work pretty well most of the time.
Excellent.
All right.
You
Well,
got any other-
we asked Code Orange these same questions, and I had the chance to talk with them. They were on the phone, on Skype with me for over an hour. I do appreciate those guys. It was actually, I got their names written down. I want to butcher them because I wrote them down here. Austin Nordman and Robbie Pomeline. I appreciate you guys talking with me. We're going to go to that interview right now, and you can kind of see what they said in response to these same questions.
So I'm Austin Nordman. I co-founded Code Orange in the summer of 2010. Our first season was 2011. From 2011 to 2013, when I graduated, I was the head of electronics and programming and multimedia. So I've had a decent amount of experience in LabView, and anyway, yeah. So and we have another member of our team.
Oh, I'm Ravi Banmai. I'm the current lead programmer for Code Orange. I've been on the team 3 years. I joined in 2012. Yeah, I'm a junior right now.
Okay, awesome. So we'll go ahead and start then with question one. What do you guys think is the easiest program for a new team to use?
I don't know what Austin thinks, but I'd say LabView probably. I mean, graphically, what I would say is just thinking about programming, especially if you've never programmed before. Like, we just got a few new kids on the team, and they've never, programming is a different way of thinking, and they've never done that before.
Sure.
And being able to visualize it with LabView is what I think that really helped, because what I started by doing for teaching is I would draw out the steps, and I didn't say we're programming. I just said, give me a set of instructions, and then taking that and porting it to LabView. I think that it made it a lot easier, as well as, it being graphical, and then text, it might seem a little intimidating.
Right,
but
yeah. Absolutely.
Yeah, so I'd add to that by saying it really depends on what your school teaches in its curriculum. I mean, for teams like, let's see, a whole lot like the Warlords, I believe they have Java in their, I don't recall whether they use C++ or Java, but it's one of the two. They have it in their course curriculum too, so all the kids, or nearly all the kids who are on the team, have also taken C++ or Java. So at that point, the programmers will all be familiar with text-based programming. Where you'd want to use LabView as a team without previous experienced programmers. Or if you just want to use LabView, I wouldn't recommend starting the build season without somebody who knows how to use C++, trying to program the robot in C++.
Right.
That's not a good idea. If anything, I mean, it's always going to be a good idea to learn how to program your robot before build season starts. But if nobody knows C++, nobody knows Java, nobody knows LabView, you're definitely going to want to start the build season with LabView.
So as being more or less LabView experts, do you guys find it kind of gives you an advantage when working with rookie teams? Like, you guys have a match coming up, and maybe we've been in a situation before where we're like, well, we ask them what are they going to do in autonomous. They're like, well, we don't have an autonomous mode. You know what I mean?
Yeah.
So have you been in that
absolutely.
situation, and has it been played to your advantage knowing?
I have
LabView
actually personally helped program other teams' robots in LabView probably 6 or 7 times.
Sure.
So yes, absolutely.
Yeah. I really haven't helped a lot of new teams, so I don't really think I could provide a lot of input. But actually, the Dana Hills team, or the team near a team that started near us, they are using LabView as well, and I guess instead of like looking through a bunch of text, I guess it's easier for them. Like we can send I forgot the name, the thing we used last year, but it's easier. I think it's easier to send stuff back and forth, like to talk about what you're doing. I guess like yeah.
Like sharing code and stuff is.
Not sharing, but I mean like communicating, like, or even following the code. It's kind of hard to text-based, it looks like a big blur of text, and you have to really look at it. Right. And be like, okay, whereas LabView, if I look at a giant screenshot of their code, it's easy to follow follow it, and then therefore easier to, debug or see what's happening, so you can maybe add on to that program if someone else wrote that program.
Cool. All right, well, let's do question 3, and that is,
can I add something to question 2?
Oh yeah, go
real
for it.
quick? So I've personally bought my first Lego robotics set. That was my first experience in programming. Lego NXT, or sorry, actually Lego RCX 2.0, even earlier than the NXT.
Yeah.
So I got started with that programming language. It was sort of like a really cruddy LabView, like cruddier than the NXT's
I
programming
remember.
language
Yeah.
LabView.
I got
So-
started with the RCX as well. Yeah, it's kind of a watered down LabView, I guess is a good way
Yeah,
to describe
very,
it.
very watered down LabVIEW. So then I bought an NXT a few years later and had a whole lot of fun with that. It's much closer to LabVIEW, but it's still really, really buggy and not quite the same.
All right, now that we're back, I was going to do question 3 and ask you guys to describe your process of programming your robot. Like if it starts at the beginning of the build season, are you guys coding as you go along? Is it kind of an end of the season thing? You need a robot in place to start doing that? How do you guys build your code?
Okay, so I can answer that. So I'm going to take the 2013 season as an example because it's the first season we really started doing any real processing on the robot, making the robot think for itself. The summer beforehand, I did quite a bit of research into how to use PID loops and camera tracking and all that kind of stuff because it's really difficult to get started with those things in the middle of the build season if you don't already know what's going on. So anyway, week 1, we started prototyping different things, physical and in programming. So week 1, we started with a flywheel, getting a flywheel to just run at a consistent RPM. Wasn't attached to any robot, just making sure we knew how to do that. So we just used one of the line sensors from 2011, put a strip of retroreflective tape on a flywheel and programmed until it worked correctly, and it paid off later because it wasn't a hassle or a difficult thing to implement that on our robot once it was all finished. And then some other programming prototypes we did were for vision tracking. So we just mounted a camera on the kitbot and pointed it at a little miniature scale model of the target and made a program that would track it consistently. We didn't actually end up implementing it because we found in practice that just doing it manually was faster than vision tracking.
Sure.
And then week 2, we started getting more into autonomous, learning how to make sure the robot can drive straight and things like that. So we made a program that would keep the robot in the same position just to sort of learn about PID loops and the drivetrain. So we'd use the encoders on the drivetrain so you could push it and it would figure out how far it went and go back to where it was before. And then made some autonomous routines that would just drive forward a certain amount or backwards, a turn or whatever, just to get a feel of how to program autonomous and how to get it to actually work. So then by week 3, you have a pretty good idea of what your actual robot is going to be doing. So at that point, we made a new program and implemented what we had already learned from the prototypes in the previous 2 weeks. And then programmed all we knew that was going to be on the robot, such as joystick programming, all the basic stuff, just a simple outline of the autonomous. It's just a basic skeleton so that once we have the actual robot finished and wired and everything, all we have to do is put it on to test it. I've seen teams that just wait until, week 6 when they're,
Right.
4 days before build season and start programming. And that really doesn't end up working out too well. So yeah, we started our main program about week 3, ready to put on the robot just to test. Week after bag day, of course, we have our practice robot, which is a very, very nice thing to have for any teams who are considering a second robot. If you have the funds, do it, absolutely. And it actually doesn't cost that much more once you already have the backbone of electronics and whatnot. It's not that much more to build a second robot. A lot cheaper than building the first robot because you don't have to put in all the money for developing it in the first place.
So do you build your practice robot second, or do you build that practice robot first?
We'd like to build it at the same time, that's the ideal.
Oh yeah,
but
well, we'd like to do that too, but we
end
definitely
up
have
having
different
to do
timelines.
it, partially during the season. And I guess I can let Robbie answer that because I wasn't there this year. So what ended up happening with the practice
This
spot?
season, what we did is, or the same last season, last season was our first practice spot, and we machined all the parts at the same time, 2 of every one. And then this season, what we did is we welded everything, and actually, like yesterday, the final welds for the practice spot were done, and we started wiring. So we have, we had like a bunch of kids who were sitting around not doing anything because they're not as experienced, and the bag day and the day before bag day we don't have time to teach as much as I would like to, but so we have them working on the practice spot, and me or the other experienced programmer, and we go over, we also do like the wiring, but we go over and we see how they're doing and see if they have something to do, kind of. So not only, the way we're doing our practice spot is building it. We built it for a little, and then I think week 4 we're like, no, we have to stop. We're running out of time.
Okay, I got you. Yeah, our team, we do things a little differently. We build a prototype that works. You know what I mean? We try to get it done like the first week, and then we build a robot that winds up being the practice bot. And when we get everything kind of set in stone, with like 3 days left, sometimes less, sometimes more. This year was like a week left in the build season, and we actually built the second one. It's got lightning holes and stuff in it because the original was pushing weight and the new one's lighter and stuff like that. So yeah, we kind of do it in reverse of you guys, is what it sounds like. We do our practice robot for what winds up being the practice robot first. Although there's been years where it's like, man, I wish we'd have bagged the practice robot. It kind of works better than the real one.
Hey, we have enough weight allowance this year to basically bring in a whole new robot.
The last thing I guess I'll ask is the common mistakes. Like, what mistakes have you guys done? What are frequent ones for you? We kind of have some frequent ones that every year kind of pop up, and we always kick ourselves. We're like, dang it is that part of the code, or do you have anything like that you guys have happen?
Well, it worked on the practice bot, so
right,
it'll probably work on the comp bot. But
Wrong.
Yeah,
unless you have a really good PID loop that can compensate for the mechanics not being consistent, you're going to need to have time to test it at competition. So the lesson learned from that: find time at competition, load in your robot earlier, whatever you need to do to find time to get your autonomous code or your driving code all working perfectly before your first match. Which is difficult to find. Even in San Diego, don't feel bad about it. Even 254, one of the best teams in the world, they were having trouble with their autonomous at San Diego. So they got it working really well at the end, but it's difficult.
What I kind of tried to focus on was, okay, how can we make it so the practice bot is going to be the exact same as a comp bot? So, for example, a lot of the things on our robot, every time we use them, we try to zero it. Like, we're working on this. I'm not sure if we're actually going to implement it, but one of the things we have is like an arm with a potentiometer on it. And what it's going to do is it's either, I'm not sure if I'm going to use like a magnetic reed switch or a limit switch or something, but every time the robot starts, it's going to move as far forward as it can go and zero that. Even if it's the exact same voltage every time, I think moving from the practice bot to the comp bot, taking out trying to say, okay, what could shift? Or, could this sensor like rotate when we could mount it on at a different angle, and then everything doesn't work, and focusing on, or not, but like when you're thinking about these thinking about like transitioning is something to keep in mind, but don't let it change your entire design.
Yeah, or more simply, keep in mind that your sensors aren't going to be the same as on your comp bot if you have a practice bot. So basically make it so you can port it to any robot.
You guys have provided a ton of great information that I think every team that's interested in taking their programming to the next level should hear. So I do appreciate you guys spending a whole hour with us.
All right, and I think that almost wraps up the programming episode, which was week number 3, or episode number 3. We're getting ready to start filming for episode 4. We've got, first celebrity, definitely a first celebrity. We got Karthik from the Simbots. Episode number 4 is going to be our logistics. Basically, how does your team organize itself? How does it split itself up in order to be entities that can come together to be a larger entity to function well. And so we'll be giving some tidbits, and we'll be chatting with Karthik on Skype.
And I think that's about it.
All right.
Thanks to Brandon for chatting with us today.
Thanks to the U.S. Army for sponsoring all 6 of these episodes. Hopefully they'll come back again next year. We're really hoping that they will. If not, there's a rumor out there that Albertsons is interested in picking us up for 6 episodes next season. So we'll find out. Maybe we'll do a 3 and 3. Maybe Army will sponsor 3 and Albertsons will sponsor 3. I like it. All right. I'm Eric Stensrud.
I'm Stephen McKay. Thanks you guys for watching, and we'll see you next week.
Yep.